Alright, for part 2, I'm going to finish this up, and hopefully someone could solve this riddle here, solve for that unknown phrase, and help me out and see what I'm asking for. So again, for 26, to finish this problem up, I'm going to combine those like terms, that 6 and that minus 5, to get positive 1. So that choice for 26 is C. That is the only one that distributes and simplifies into 5x plus 1. The others do not. For 27, I'm going to have you plug in three numbers, 0, 1, and 2 into x. So when I plug it in, where that x is, I'm going to plug in 0 for x. Remember, anything to the 0 power, when you plug that in, is not 0. Anything to the 0 power is 1. So a common mistake is people think that's 4 times 0 right there, which is not the case. That is 4 times 1. The person that makes the mistake and thinking that's 4 times 0 and gets 0 right here will probably choose choice B by mistake. Plug it in 1 for x. Again, do the math. 4 times 3 to the first power is 4 times 3. When I plug in 2, be a little more careful. Again, I'm going to erase that and change that to 2. Order of operations says do the exponents first. Do not multiply 3 times 2. That is not 6. This is 3 times 3, 9. So that gives you 4 times 9. And of course, the right choice for that one, 4, 12, 36, is going to be choice C for that one. And again, I'm showing you the common mistake of thinking 3 times 0, or 3 to the 0 power, is 0. So that's not the case. Oh. Alright, the next one, I'm going to solve this by graphing. So I'm going to take that. That's an equation. That's not an inequality. So make sure you make that fix. That's an equation. So I'm going to solve that for y. Now I'm going to write equation in there. So to solve this problem for y, I'm going to take that and solve it by subtracting 4x first to get that y by itself. Add or subtract any terms first. And then do my division, dividing everything by 3. Again, dividing the left side by 3 gets y all by itself. And then when I split that up, that gets me y equals negative 4 over 3x. Plus 6 over 3, which simplifies into 2. That tells me I have a y-intercept of positive 2, which would be right here on the y-axis. And then from there, every time I go over 3 boxes, I go down 4. Over 3 for my run, down 4 because my rise is negative. Draw my line through it because it's an explicit equation, which always has a line drawn through the points. Write my equation next to my line. Next problem has you take that inequality and also solve that for y. So whether it's an equation or an inequality, solve for y first, get it in slope-intercept form. So to solve that for y, I'm going to subtract x on both sides. I'm going to bring down the y. I am not going to flip my inequality. I'm not dividing or multiplying by a negative number, so leave it alone. That 2 tells me where on the y-axis to start. That negative made into my slope is negative 1 over 1. So that from that starting point of 2, every time I go over a box, I go down a box. That line will be a solid line because of my inequality with a line drawn under it. That is more than or equal to. More than is always shaded above the line no matter how it's drawn. So shaded up here. Even if the line was slanted like that, it would be shaded above. So more than shade above. And again, when I shade above, any point for x and y in this shaded area and any point along this line will work if you plug it into that inequality. It will give you a true statement. All right, on to number 30. B. On number 30, I'm going to have you distribute and then combine like terms. So I'm going to take that 6, leave that 6 alone. I'm going to take that negative 3, and I'm going to distribute it. So here we go. So 6 minus 3, x minus 1. I'm going to take that negative 3 and multiply by both x and negative 1. Negative 3 times x gives me negative 3x. Negative 3 times negative 1 gives me positive 3. Now combine the like terms, which are the two numbers. Leave that negative 3x alone and bring that 9 when you combine 9, 6, and 3. And again, simplified gives you negative 3x plus 9. Alright, number 31, I'm going to convert that to slope-intercept form, which is taking that equation and solving it for y. So the first step, again, to solve that for y, look to see if there's any terms around it to add or subtract, which is that 4x. So I'm going to subtract that away. Make sure you bring down the negative with the 3y. A lot of people just bring down 3y. Bring down the negative with the 3y. Be careful. Make sure you're doing the opposite of multiplying by negative 3, which is dividing by negative 3. Divide this side by negative 3. Divide that side by negative 3. That negative 3 splits into two parts there. Negative 3 over negative 4, or negative 4 divided by negative 3 simplifies into positive 4/3. And 6 over negative 3 simplifies into negative 2. So that line would have a y-intercept of negative 2 and a run of 3. Rise of 4 slope. Run of 3, rise of 4. With a negative 2, 0, negative 2 y-intercept. Alright, on to the next page. For 32, for this one, I'm going to have you solve this and then graph it on a number line. So this one, 3x plus 14 greater than, more than 5. Less than is the inequality going the other way. That is more than. So for this, to solve, start by doing inverse operations. Get rid of that 14 by subtracting 14 on both sides. Bring down the 3x. 5 minus 14, be careful, is negative 9. Be careful here also. You are not dividing by a negative number. Even though 5 minus 14 is negative 9, that does not switch the inequality. Only dividing by a negative number switches the inequality. So leave that inequality alone. Last step, divide by 3 gives me x more than negative 3. So on my number line, I will do a open circle because of that inequality being just plain old more than, and it will be shaded off to the right because more than is always in the increasing direction to the right. So negative 3 open circle, shaded arrow to the right, more than. Alright, 33, changing that to standard form. Standard form has y and x together with that x term first and that x term made positive. So y equals 3x minus 4. I'm going to start by subtracting that 4x to get it over there with the y. Subtracting 3x on both sides, I should say. That cancels away. Even though I subtracted 3x and 3x plus y equal negative 4 looks different, it's still equivalent to this first equation up here. They're still equal even though they look different. Again, doing inverse operations on either side of my equation doesn't change it structurally, just changes the look of it. And now right there, I cannot have that first term be negative, so I'm going to multiply by negative 1. But remember to multiply all three terms by negative 1. So that will give me positive 3x minus y equal positive 4. I will change this to minus y. I will fix that, I promise. So with that eraser and that being negative y, that answer is 3x minus y equals 4. Alright, the next problem is have you read this graphed function. So the first problem, 34, has you ask a max, a min, or both. This graph only has a minimum. Because this arrow is shooting off up into space here forever, going off into infinity, there's no maximum. There is a minimum though, this lowest point of the graph right here, and then that point would be written as a rounded coordinate, but it does have a minimum only. For increasing intervals, I'm looking to see where that graph increases from left to right. And what I mean by that, when you're coming from left to right, where you go uphill is where the graph is increasing. So for this graph, I'm increasing from left to right, right here in this section, and then right here in this section. I'm decreasing when coming from left to right, and I go downhill. Once you identify what it's asking for, where it's increasing, right here and right here, you map that area out from left to right, looking at the x-axis numbers. So that would be negative 1, 2, 3, 4, 5, from negative 5 to 0 on the x-axis. And you would use square brackets because those are closed circles. So from negative 5 square bracket to 0 is the first place it's increasing. And then from here, 1, 2, 3, 4, from 4 on the x-axis to infinity, rounded bracket, always rounded bracket in infinity. Where that graph is decreasing, where that graph is going down, L. If you look back on that graph, it is going down in two sections. It's going down right here, and it's also going down right here. So once you identify what it's asking for, map it out. This measured from left to right, measured with a rounded bracket because that open circle starts from negative 7 and goes here to negative 5 square bracket because that's a closed circle. Use the union symbol because, again, when you have more than one section, use that union symbol right there. From 0 to 4 square bracket because those are closed circles. So decreasing from rounded bracket, negative 7, negative 5 square bracket, and from square bracket 0 to 4 square bracket. Make sure you put that union symbol in there. For range, range is measured from bottom to top, looking at the y-axis numbers. Domain is measured left to right, looking at the x-axis numbers. So this first problem is asking for range, which is measured from the bottom of the graph up. And then you look at where that bottom lines up with the y-axis. So the range from negative 2 on the y-axis, square bracket, because that's a closed circle, to infinity, rounded circle, a rounded parenthesis on that infinity. Domain is measured left to right where it lines up with the x-axis. So for domain, this measures from negative 7, rounded parenthesis here because of that open circle, to infinity to the right. So again, range from bottom to top, lined up through the y-axis from negative 2 to infinity, rounded. Domain measured from left to right where it lines up through the x-axis from negative 7 rounded to positive infinity. So that would be my range and my domain. And then again, that would be, yep, negative 7. All right, for the next problem. For these, I'm giving you the value for x, and I'm going to have you find the value for y, and then vice versa. I'm going to give you the value for y and have you find the value for x. So here we go. For these next problems, for number 39. And again, make sure you do this problem the right way. Listen to my words. Do not do this problem the way I wrote it, because I do this problem the opposite. This problem says, where is the graph less than or equal to 0, not more than. So right here, that's a mistake. So this answer is going to be actually up here, but I'm not looking for. I'm looking for where that graph is less than or equal to this 0 line. So where it's less than or equal to is this section right here. I, by mistake, did more than or equal to from this section up, measured from left to right from here to infinity, but that's not correct. On the exam, it will be x less than or equal to. So make sure for this graph, less than or equal to would be from about here, and that looks like about negative 1, 2, 3, 4, 5, 6, from about negative 6 square bracket to about negative 3.5 square bracket on the x-axis. So where this graph is less than or equal to 0, listen to my words, goes from negative 7 square bracket to negative 3.5, less than or equal to 0, not more than or equal to 0. So make sure you're okay with that. Square bracket negative 7 to square bracket negative 3.5, where it's less than or touching that 0 line. That is where it's more than from negative 5 to infinity, but make sure you're not doing that. Listen to my words. All right, for these problems, I give you the x number, and I have you find the y number. So for this problem right here, I'm going to erase this. And again, I am giving you f of negative 5. And again, that is me giving you the x number, and you use it to find the y number. So go to negative 5 on the x-axis, go down until you hit that line, and look over on y to see what you get. So again, if I give you negative 5, this is me giving you x. Find x is negative 5 on the x-axis. Go up or down until you hit that line, and when you do, look over at y to see what you get, and that's where I get negative 2. For the next problem, I give you instead the y number. So for number 41, I give you the y number instead. So again, on that one, you go to that 6 on the y-axis and then use it to find out what the x number is for that graph. So up to 6 on the y-axis here, and again, when it's written as f of x equals 6, that is me giving you the y number and asking you what the x number is at that spot. So x is 6 is up here on my y-axis. Look left or right until you hit that line, and when you do, look down and see what the x number is. So when y is 6 at that line, the x number is 6. So make sure you know how to do those problems. The last problem, number 42, says, how do you know this problem is a function? And I'm going to have you do the vertical line test. If you could run a vertical line through your graph and it only touches it in only one place and all the way through, that means for every input there is only one output. For a function to be a graph, every input only has one output. A vertical line touching a graph in only one place shows for every input there is only one output. If a vertical line touched it in more than two places, that would show for that input there are more than one output. It would fail. But this one passes, so make sure you tell me about that. Passes, and for every input there is only one output. Alright, the last problem for this one, I'm going to have you change this to a word problem. So hot dogs, or this is where it changes to an inequality. So hot dogs, I'm going to have you use the variable x. Hamburgers, I'm going to have you use the variable y. So $2 per hot dog will be written as 2x. $3 per hamburger will be written as 3y. You have at most to spend $25, so you will use the inequality less than or equal to. So this inequality is 2x plus 3y is less than or equal to 25. You do not want to spend more than 25. You could spend 25 or less than 25, but not more. So that inequality is 2 times x plus 3y less than or equal to 25. To graph it, I'm going to have you solve this inequality for y, graph it, and then pick 3 points that show possible solutions in that shaded zone. So that inequality is $2 for every hot dog plus $3 for every hamburger less than or equal to 25 bucks. To solve that for y, take away 2x, and then I'm going to divide everything by 3. That will give me 3y equals negative 2x plus 25. When I divide by 3, That gives me y is less than or equal to negative 2/3 x. I'm going to round 25/3 to the nearest whole number to make this graph a little bit easier for me. Because again, I'm just looking for points in the shaded zone. I could be a little bit imprecise here. Instead of graphing 8 and 1/3, which 25/3 is, that would be kind of a pain to do 8.3. I'm going to use the nearest whole number, which is 8. So if I use 8 and start up here at 8, I will still be okay. And then every time I go over 3, I go down 2. Over 3, down 2 because of my slope. I'm going to draw my line. It will be solid because of my inequality. I will shade below because this is less than. I will only use the part of my graph that's going to be in the quadrant 1 because this is a positive real world problem. I do not want to use any of my negative quadrants. So again, I'm only going to use that first quadrant for my whole graph. Again, my whole graph, only use quadrant number 1 for the graph. Y is less than or equal to 8, over 3 down 2, over 3 down 2, solid line, shade below. Now for my solution, I could take any 3 points in this shaded area. Any point in this area will plug in and satisfy this inequality. What I do here is I pick a few just random points here inside that shaded area. I pick 3, 5. What that means is the combination of, for every 3 hot dogs I buy and 5 burgers, 3 times 2, 5 times 3, it keeps me under $25, but it gives me a combination of hot dogs and hamburgers I could buy. Because 3 times 2 is 6 plus 15 is less than 25, would keep me under the limit. All I need to do is pick any 3 more inside this shaded area. Do not pick any points outside this area because that will put you over this price. These other combinations I'm doing here, again, show a combination of 7 hot dogs to 3 hamburgers, still would keep you under this limit of $25. This is a combination of 9 burgers and 9 hot dogs and 1 hamburger. Someone who wanted to be real even might want to choose this point right here at 5, 5 would be 5 hot dogs for every 5 burgers. But again, solve it for y, graph it, choose any 2 points in here, and then on your paper make sure you label your points as this would be 3 hot dogs and 5 hamburgers, 7 hot dogs, 3 hamburgers, 9 hot dogs, 1 hamburger. Make sure you show me that you understand what those units are. E. Good luck with this, and I will see you tomorrow.